Welcome back! When I left off, I had just finished taxi testing the nacelle. Here's what I've done since then. I started the upper deck, which will become the bottom of the wing. I left its section unglued so I could test different inlet ducting configurations. In the previous version, I just mounted the fans on the firewall and used the stock bell mouths, which wasn't optimal for airflow in the slightest. Static thrust was improved slightly by adding plenums to eliminate dead space and massively enlarging the landing gear holes. For this version, I had to modify the bell mouths to fit a tighter spacing, and I also made another set of bell mouths from laminated foam board and a 1/2-inch roundover bit for a router. Here's the results from the thrust test I did. I found the optimal configuration was my custom inlet. I installed it, added some small bits which eliminate potential stagnation points in the airflow, and sealed up the nacelle for good. I was able to achieve the same static thrust as previous with more reasonably sized landing gear holes and more constricted thrust tubes. I aim to surpass the original by using better batteries, which will have less voltage drop under load due to having a lower internal resistance. After a little side project, I got back to building the upper deck. I started with the carbon fiber carry-through spar and ribs, then moved on to the wiring. I'm running the primary flight control surfaces, which are the canard, 2 elevons, and 2 rudders, and the receiver off of a 15-amp BEC. At the end of the main servo leads, I installed some aluminum polymer capacitors. They should help with voltage regulation, combat electrical noise, and soak up small current spikes. For safety, I put the retracts, brake servo, and no steering servo on a separate 5-amp BEC. I braided the motor to EDF wires to keep them together, as well as the battery to ESC wires. It looks sort of nice. I also added a bit of reinforcement webbing above the nose gear. It'll be carrying a bit less than half the weighted plane on the ground, depending on where the CG is. Combine that with braking forces and you've got to have a strong structure. Next was building the wings. Previously, they had been built separately from the fuselage, which left a bit of a mismatch and a gap between the two. To get around this, I planned on building and sheeting the wings on the fuselage as one piece, and then cutting them apart, the idea being that this would leave a minimal seam. The wing itself is fairly simple structurally. There's one main carbon fiber spar placed at the aerodynamic center of the wing, and a secondary foam spar and a bunch of ribs. To keep the wing from twisting around the main spar, I added little anti-rotation tabs. These are made of 1/8-inch plywood and installed while the wing was in the plane. They also retain the wing by means of 2 screws per side that can be screwed flush for the lower wing surface. I installed the servos with wood reinforcement, which is a vast improvement over just gluing them into the foam. 1 small carbon fiber bit to keep the trailing edge from deflecting under control surface loads, and I inset a little bit of foam whose paper would serve as the elevon hinge. I prepared the wing sheeting, taped it along the leading edge, and bent it over the wing by section. I trimmed the first half down centerline and used a long knife to cut from the bottom seam through the top fuselage, separating the wing. This process was repeated on the opposite side, yielding 2 wings and a center fuselage. The holes for the vertical stabilizer slots were cut, as well as the necessary slots and bevels for the elevons. These were later reinforced with hot glue on both sides. The result is quite a lot better than the original. The seam joins well, even if it is a bit ragged. I probably should have used a sharper knife. It's also incredibly easy to slip the wings into the correct position. There's zero misalignment because they were installed when the 2 pieces were joined. This is vastly superior to the separately designed built wings of the first model, even if I had to deal with the frustration of sheeting such a massive surface. They don't need to be forced together, they're just joined together effortlessly and seamlessly. It's amazing. Here's a quick test of the retracts, which I plan to use on the first flight. They seem to be fairly reliable. Here's everything I've built so far, minus the canard. It's definitely starting to look like a plane, although it is looking a bit weird without the swan neck and the nose that so characterize the XB-70. Anyways, that's all I've got for this build update. I'm starting to work on the swan neck and nose, which will be done with pink foam and hot wire. If you'd like to preview the changes I plan to make, check out the forum post linked in the description. Leave any likes, dislikes, comments, suggestions down below, and consider subscribing if you'd like to see future build updates. See you all next time.